All right, here I'm going to go through two examples of following this graphing rational functions process. This should help you with your part 3 homework. We're graphing these rational functions following these 7 steps here. I did 2 examples. They are not the same as your homework examples. There are other ones, but you can follow along with the steps, and I think that'll help you do the ones for homework. So I'll just kind of go through, did 2 problems here. I'll go through them step by step. So this is the function that we're given. All right. And our first step here, I'll back up, is to simplify by factoring the numerator and denominator. All right. So I factored this here. The top of my function factors to x plus 4, x minus 2. And the bottom here factors to x plus 1, x minus 2. Okay. And then here I cancel out these x minus 2's. And when I cancel it out, I end up with this simplified form, right? So it's factoring and then canceling out, so I end up with this form here. My second step is to find and plot the y-intercept, if any. So we can do this by plugging 0 in for x, finding f of 0. When we do this, we could plug 0 into this original function, or we can plug it into the final one here. Does not matter which one. I think for this one I plugged it into the original. For the second example I'm going to do, I plugged it into this one, just to show you it works either way. So here I plugged in 0 for each x here, and when I do that I just end up with negative 8 over negative 2, which simplified is 4. So that's going to give me this point 0, 4 on my graph. That is my y-intercept when x is 0. So as you can see down here on the graph, which I made up, I put that point 0, 4 here on the graph. And then my third step says to find the zeros of the numerator. Okay, then plot these. These are going to be our x-intercepts. Right. Basically what this is, if our numerator equals 0, then the whole function equals 0. Right? 0 divided by any number is 0. So you can take this whole top and set it equal to 0. I think it's easier to use this simplified form. You have to use the simplified form because this is canceled out. Okay, so if I set the numerator here equal to 0, x plus 4 equals 0, and solve for x, I get negative 4. So that's going to give me this point negative 4, 0 on my graph, which you can see I put right here. All right, that is my x-intercept. There is no other x-intercept on my graph. And then step 4, find the zeros of the denominator. Okay, the zeros of the denominator are going to be the wholes or vertical asymptotes. I wrote on here, make sure that you find the y value of the whole. I sent out notes the other day on how to find that, but I'll also go through that for this example here. Okay. So from this factored form, I have x plus 1 here. I know that that is going to be a 0 of the denominator. If I set that equal to 0, I get x equals negative 1. Because that did not cancel out, I know that x equals negative 1 is going to be a vertical asymptote. So here on the graph, to show this vertical asymptote, I put this dotted line. That shows that we have a vertical asymptote here. It is never going to cross through that asymptote. It is only going to approach it, get close to it on both sides. X minus 2 cancels out here, so I know that that is going to give me a whole at x equals 2. Okay. Following the notes, I don't think I have them here, but following the notes, what I want to do is I want to plug this 2, where I have my whole, back into the fully simplified and factored out function. I posted notes on how to do this with an example of that. Okay, but I'm plugging 2 in here for x. All right, plugging 2 in. When I do that, I get 6 over 3, which simplifies to 2. That tells me I'm going to have a hole in my graph at the point 2, 2. As you can see here, 2, 2, I put a hole here, an empty circle. Our graph is going to go up to that point, it's going to be a hole, and then it's going to continue on the other side of that point. You'll see that when I go to fully graph this. Step 5 says we want to find and sketch the horizontal asymptotes, if there is any, by using those rules of horizontal asymptotes. Okay. So n equals m, right? The degree of the top equals the degree of the bottom. So we look at the numbers out in front, they are both 1. So we have y equals 1 over 1. So we have a horizontal asymptote at y equals 1. As you can see here, I put a dotted line at y equals 1. Okay. That tells us it's never going to go through this line. It is only going to approach it as we go all the way to the right and approach it as we go all the way to the left. So what I did next was, I already have these next points on my graph, but essentially what I had was I only had this point here, my vertical asymptote, and this point here, as well as the hole. So what I basically did was I found a point to the left of this intercept, in between this intercept and the vertical asymptote, and then in between this point and the hole, and past the hole. What that does is helps me make the graph more accurate. As you can see here, I chose -5 because -5 is to the left of this point that I already have. So if I plug -5 into my function here, the final point, you could have plugged it into this one, but it's easier to plug it into the final factored and simplified version. When I do plug in -5, I get 1/4 as my y value. As you can see, I tried to put that around 1/4 here. Then I wanted to find a point in between -4 and the vertical asymptote, so I chose -2. When I plugged in -2 and simplified, I got -2 here. So I have the point -2, -2. All right. Now, as I can see here, I have a few points here, so I can make an accurate graph here. I know that on this left side, it is going to get closer and closer to that horizontal asymptote. It's never going to touch it, but it's going to get closer to it. And then same thing as we work our way around, it is going to go through these two other points I have, and it is going to approach this vertical asymptote, but never touch it. Okay, that is how I create my graph. That's step 7, making the smooth curve. Now if I look at the right side here, we haven't gone over this point or this point yet, so that's how I came up with them here. I wanted to find something in between this point and this hole. So in between here was 1, so I plugged 1 into the function and got 2.5. As you can see, I put this point at 1, 2.5. And then I wanted something to the right of this hole, so I plugged in 3. When I plugged in 3, I got 7/4 or 1.75. So I also put that point on my graph. Now I can connect these points that I have here, knowing that it does not go through that hole. Okay. And then I want it to, as it gets closer to the vertical asymptote, approach it. And as it goes all the way to the right, approaches my horizontal asymptote. So that would be what this graph looks like following the 7 steps. I have another example here that I'll go through as well. We're already like 8 minutes in, so maybe I'll go through this one a little quicker. Following the same steps here, I labeled them out for you. I factored both the top and the bottom, and then canceled out what I could cancel out. We see here how we both of them have an x. Those x's cancel out. Both the top and bottom have an x minus 1. Both of those cancel out. So on the top, if both of these cancel out, all we're left with is 1. On the bottom, all we're left with is x plus 3. So this is my fully simplified, factored and simplified version. The next step is to find your y-intercept by plugging 0 in for x. As you can see here, I plugged 0 in for x in this fully simplified part. When I do that, I get 1/3. Okay, so I have this point 0, 1/3. Okay. I did put that in here on the graph. What we'll see later is that this y-intercept is actually a hole. I'll get to that with the next couple steps. Okay. Then part 3 says that we want to find the zeros of the numerator. If I look at the numerator here, 1, I want to set that equal to 0. We have 1 equals 0. 1 can never equal 0, so we say that there is going to be no x-intercept. Okay, so I don't put an x-intercept on the graph. Part 4 says to find the zeros of the denominator. So what I did was I set each of these parts equal to 0. The first part, x equals 0, that's going to be a hole. So what I want to do to find the y value of my hole is plug 0 back into my function. If I do that, I get 1/3. So we have a hole at 0, 1/3. We see how this is the same as our y-intercept, so that is why I put a hole in here rather than a point. Okay. Then the next part, x plus 3, because this did not get canceled out, I know that x equals -3 is a vertical asymptote. So over here at -3, I drew my dotted line. I know it's going to approach that on both sides. Okay. And then lastly, x minus 1, if I set that equal to 0, I get x equals 1. Because that canceled out, I know I have a hole. So when I plug 1 back into my function, I get 1/4 as my y value. Okay, so we have a hole at 1/4. which I tried to put right here. It might have been more helpful if I made these values go up by a smaller number, but that's okay, this still works. And next step, finding our horizontal asymptote. Because the degree of the top 2 is less than the degree of the bottom 3, we know that we are going to have a horizontal asymptote at y equals 0. So I can put that in here. You can't really see that, but I know I have a dotted line here on the axis y equals 0 because it shouldn't cross through that value. Okay. Sorry, I'm a little shaky. And then the 6th part is finding points beyond and between. Okay, so I didn't have any points over here to the left of this vertical asymptote. So that's why I plugged in -4. I wanted to figure out whether it was up top here or the bottom here. So when I plugged in -4, I got -1. That gave me this point here. Okay. I don't have any other points here. I could have maybe plugged in -5 to find another point, or maybe -3.5 to find another point here. But I know that this is going to, as it goes all the way to the left, approach my horizontal asymptote, which is the axis. And as I come closer to -3, it's going to approach the vertical asymptote. So that's how I know it's going to get that shape there. Next, over here, I only had these 2 holes. These 2 points I came up with after. I wanted to find something in between the asymptote here and this hole. So that's why I plugged in -2. You could have also plugged in -1. When I plugged in -2, I got -2, 1, which gave me this point here. I know that from this point it is going to, because I can see it's going up here, I know it's going to approach the asymptote this way. And then I know it's going to come and touch to this hole and then to this hole. Then I wanted to figure out something to the right of this hole here. So I plugged in 2. You could have plugged in 3 or 4. Does not matter. But when I plugged in 2, I get 1/5. So I tried to put that here at 1/5. So it's going to go to that point. And I can see how it is going to now approach the horizontal asymptote that way. So here's 2 examples. Hopefully this helps you when doing your process to doing part 3 homework. Okay. It might help you if you label out your 7 steps like I did here. Hopefully this helps. Let me know if you have any questions.